Welcome to the Enhanced Ground Proximity and Warning System lesson. This lesson will teach the fundamental logic and display features of the EGPWS system. The primary function of the Ground Proximity Warning System is to warn the flight crew of a potentially hazardous flight path or configuration relative to the terrain. In a large passenger aircraft, two possible system installations can be found: Basic GPWS and Enhanced GPWS. The basic GPWS functions alert the crew to an unsafe terrain closure rate. Basic GPWS uses the following aircraft inputs to generate alerts: radio altitude, gear and flap configuration, glide slope deviation, and bank angle. The enhanced features, if included, overlay aircraft position on a terrain data map. This is used to create additional terrain warnings and an additional safety margin. EGPWS also allows the crew to display a terrain map on the aircraft's navigation display. In the 1960s and 70s, a string of accidents occurred involving controlled flight into terrain, or CFIT. CFIT can be defined as an accident where a functioning aircraft, operated by a qualified crew, impacts terrain. This spurred regulators to develop an aircraft-independent system that provides flight crews ample warnings of imminent ground contact. The GPWS system was the result of this effort, while the generic phrase Terrain Awareness and Warning Systems, or TAWS, was coined to describe all current and future systems that meet certain standards. In 1974, the FAA mandated all large passenger aircraft to include a GPWS system. The more advanced eGPWS system was introduced in 1996. Since the system was required in 1974, there has not been a single CFIT fatality in U.S. airspace. While each aircraft's individual GPWS controls may vary, most configurations include the following: test switch, flap override switch, glide slope cancel switch, GPWS annunciator light, and display controls. Selecting the GPWS test switch will cause the system to initiate a self-test. The test normally includes an aural component where all GPWS warnings are played.
Glide slope. Pull up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up. Sink rate. Pull up. Terrain. Pull up. Don't sink. Too low. Terrain. Too low. Gear. Too low. Flaps. 10, 20, 30, 40, 50, 1,000, 2,500.
If a fault is detected, a visual or aural annunciation is produced for the crew.
GPWS in op.
The rest of this topic covers the 6 different alert modes of the GPWS. These modes provide both visual and aural cautions or warnings if one or more of the following conditions exists: excessive descent rate, excessive closure rate to terrain, descent after takeoff, insufficient terrain clearance, descent below glide slope, and minimums and excessive bank angle. This topic discusses aural and visual warnings that are typical for most air carrier GPWS installations. Please consult your manual for specific system information. Mode 1 provides an alert for excessive descent rates near terrain. GPWS monitors descent rates relative to radio altitude. When an excessive descent rate is first detected, the sink rate aural sounds, and both of the GPWS lights illuminate.
Sink rate.
If the descent rate continues, the aural changes to a warning.
Pull up.
The logic for this mode changes based on aircraft position relative to the ILS glide slope. In general, the warning is more sensitive when below the glide path. Mode 2 activates warnings based on terrain that is rising quickly. This function is based on radio altitude and how rapidly the radio altitude is changing, but does not factor in descent rate. This mode features two submodes, 2A for flaps not in landing position, and 2B for flaps in landing position. While the logic between the two varies, the basic function and warnings are similar. For both modes, the GPWS annunciator lights will illuminate. When an excessive terrain closure rate is detected, a terrain caution sounds twice.
Terrain, terrain.
In Mode 2B, an additional pull-up aural sounds if the landing gear is not down. In Mode 2A, if the terrain closure continues after the terrain caution sounds, the pull-up warning sounds.
Pull up.
In Mode 3, the GPWS provides alerts for excessive altitude loss after takeoff or go-around. If the system senses a significant altitude decrease during takeoff or go-around, the alert is activated and the following indications are given. GPWS lights illuminate, and the don't sink aural sounds.
Don't think.
When altitude increases for a set amount of time, the Mode 3 warning is canceled. Mode 4 generates alerts based on altitude, airspeed, and configuration. This differs from Mode 1 and 2 because it does not factor in closure or descent rates. This alert has three parts. Mode 4A, too low gear. Mode 4B, too low flaps. And Mode 4C, unsafe altitude during takeoff or go-around. For all alerts listed here, the GPWS lights will illuminate on the instrument panel. Mode 4A. The Mode 4A alert is predicated on the landing gear not being down and locked. At low altitudes and at higher airspeeds, the too low terrain aural sounds.
Too low. Terrain.
At a different altitude and airspeed, the warning aural may change to too low gear.
Too low. Gear.
This warning is usually inhibited below 50 feet. Mode 4B. The Mode 4B alert operates in the same manner, but is based on flaps not in the landing position. At higher speeds, the too low terrain aural sounds. At slower airspeeds, the aural too low flaps sounds.
Too low. Flaps.
Mode 4C. Mode 4C calculates a clearance floor during takeoff and go-around. This floor is generally 75% of the highest AGL altitude. The too low terrain aural sounds if the airplane descends after takeoff, or the terrain below the airplane rises more steeply than the aircraft is climbing. Mode 5 alerting notifies the crew of significant deviations from the glide slope. If the aircraft deviates below the glide slope into the soft alerting region, a glide slope message sounds at half volume, and the below glide slope annunciator switches illuminate.
Glide slope.
Aural alerts will increase in frequency as AGL altitude decreases. If the deviation continues into the hard alert region, The aural warning repeats at an increased volume.
Glide slope.
Pushing either below glide slope switch light for 1 second will cancel the aural warning. The below glide slope lights remain illuminated to indicate the mode was canceled. Mode 5 automatically cancels below 50 feet AGL. Depending on your aircraft's warning and pilot alerting systems, the GPWS may include a Mode 6 for approach minimums and excessive bank angle. This mode sounds the minimums aural when descending through the decision height setting.
Minimums.
The bank angle alert sounds for varying bank angles depending on AGL altitude.
Bank angle.
For most aircraft, the angle at which this alert is activated will vary based on aircraft radio altitude. GPWS logic for aircraft being in the landing configuration is partially based on flap position. In situations where a malfunction requires landing with zero or partial flaps, unnecessary GPWS alerts could result. A GPWS flap override switch is installed on the pilot side console to inhibit associated aural alerts in these situations. When the switch is selected, alerts based on flap position are inhibited. eGPWS is a system that uses aircraft position to create additional terrain alert and display functions in addition to the basic GPWS system. These features include terrain awareness display on the navigation display, auto pop-up terrain display, terrain or obstacle alerts,
Terrain ahead. Pull up.
and look-ahead alerts. The eGPWS terrain database uses topographic surface data to create a digital elevation matrix overlay. This overlay is like a computer-generated terrain map that includes all terrain features and obstacles. The terrain map also takes into account the nearest runway location. This prevents unwanted alerts during approach and landing. The eGPWS computer digitally positions this overlay map with respect to airplane position from the navigation system. Meanwhile, another part of the eGPWS computer performs threat analysis on the computed terrain data. To accomplish this, caution and warning envelope boundaries are calculated below and forward of the airplane path. The outputs of the terrain map and threat calculations are displayed on the navigation display, or ND. The terrain display is range adjustable, with each pilot being able to select a different range value. Terrain information is displayed on the navigation display as varying patterns of green, yellow, and red. Each specific color and intensity represents terrain below, at, or above the aircraft's altitude, based on the aircraft's position with respect to the terrain or obstacle in the database. The density and color are functions of the proximity of the aircraft to the terrain. Look-ahead terrain alerts are depicted as solid yellow or red. Dotted green, yellow, and red colors indicate non-alert terrain at the following altitudes. Green, terrain between 2,000 feet below to 500 feet below the aircraft's altitude. Yellow, terrain 500 feet below to 2,000 feet above the aircraft's altitude. Red, terrain more than 2,000 feet above the aircraft's altitude. Other possible display colors include cyan and magenta. Cyan indicates terrain equal to 0 feet MSL. Magenta depicts terrain with an unknown elevation. If no significant terrain exists, terrain is more than 2,000 feet below the aircraft, the display is black. The Peaks Mode display, if installed, includes 2 elevation numbers in addition to the normal GPWS display. These indicate the highest and lowest terrain in MSL being displayed on the ND. The colors of these numbers match the color scheme for the rest of the eGPWS display. If the screen is all black or all blue, indicative of flying over relatively flat terrain, only a single number indicating the highest point is displayed. Some eGPWS installations include an auto pop-up feature. This provides the pilots a quick situational awareness aid during a terrain alert. This function will automatically display the terrain map on the ND anytime a terrain caution or warning is triggered. Terrain alerts are generated anytime the aircraft enters an eGPWS caution or warning region. These regions are based on the Terrain Clearance Floor, or TCF, and look-ahead terrain information. Although there are multiple envelopes that will generate alerts, the indications for all eGPWS terrain alerts are the same. Terrain floor alerts are a function of airplane altitude and descent rate compared with nearest runway position and altitude. Caution and warning envelopes generate an associated alert. Airport elevation and positions are factored to prevent nuisance alerts during takeoff and landing. Look-ahead alerts rely on aircraft ground speed and turn rate information to project future position. A caution envelope is computed to estimate when the aircraft is between 40 to 60 seconds from terrain impact. The warning envelope exists when the aircraft is less than 40 seconds from impact. During a caution alert, the terrain that has violated the caution envelope is depicted as solid yellow on the terrain display. A terrain caution will normally include an associated ARL alert.
Caution, terrain.
The ARL warning will repeat for as long as the aircraft remains in the caution envelope. If the aircraft continues towards terrain and enters the warning envelope, a terrain warning is triggered. Indications for a warning are the same as for a caution, except terrain on the ND changes to solid red, and the ARL warning changes to
Terrain ahead. Pull up.
Some aircraft allow the pilots to inhibit the enhanced features of the eGPWS in the occasion GPS aircraft position is unreliable. This prevents spurious or incorrect terrain alerts. When this inhibit is selected, the TCF and look-ahead alerts are inhibited, and the terrain display is removed from the MFD.
That is incorrect. That is incorrect. That is incorrect. That is incorrect. That is incorrect.